Now let's talk about another tool that is really useful and then you need to learn while working with the front end or now even with the backend frameworks. So basically, you have the package managers. We have these packages or dependencies that you need a tool for to manage actually. So there are these command line tools that is called npm, yarn, and pip or compose that you can use. Npm and yarn are basically the same, but they're not that different, but just the APIs are a bit different, and you can use them in order to manage your packages in your application. Pip is basically used by Python, so you can use this package manager for Python, and it's good to learn. Or even if you're learning the Python programming language, or you're learning any Node.js or JavaScript framework, then it will be the first thing that you will be dealing with. So, but these are the good to know that what package managers do we have. So basically, Composer is used by PHP, and when you're dealing with PHP frameworks, then you will be using it a lot. So yeah. Now, in here, you can see that I'm pointing to npm.js. So sometimes or most of the time, if you want to create your own package with JavaScript or any programming language, then you can just publish it on npm.js using npm or yarn. And you can learn about npm.js as well. So for example, if you have some APIs or SDK tool that you learn or some packages that you want to install on your application, then you can just go to npm.js or Yarn website and you can download the package from there directly. So that is what basically npm.js is. It's basically a server that holds all of the packages and people can publish their own packages into the npm.js registry. Now let's talk about version control. So if you are working on a real world application or even your personal projects, but then you want to manage your application. For example, you create a small application and you don't want to lose it, then you can just use a Git tool for that. That is basically, you can just push your code to any of these repositories. And for example, you created an application and after a few days you want to make some changes to that code. So you can just do your changes and then push the code to any of these platforms and that will store your code over there. So you can learn about that as well. But the primary thing here, or the key thing here, is to learn basically the Git and how can you version your website. So it's basically useful and it's been used by companies where, for example, a lot of engineers or developers are working on a single application or different services of an application that's been managed here on GitHub, GitLab, or Bitbucket. That's basically the central repository for your code where everyone can pull and push their code to. And you can create different versions of your code. For example, with new features, you can push or publish your new version of application. So that is basically a must to have or a must to learn tool basically. And then if you want to create some desktop applications in JavaScript or using the web technologies, then you can use Electron.js for that. So Electron.js basically lets you create desktop applications using HTML, CSS, and JavaScript. And of course, you can use the front-end frameworks like React or Angular or Vue or whatever you're comfortable with. And there are a lot of applications built on top of Electron.js. So a few of them are basically Skype and also Slack. It's been built on top of Electron.js. So yeah, you can create your application. It's a good to have or nice to have, but it's not required actually. And if you want to learn, for example, if you're already familiar with JavaScript and you're already familiar with HTML, CSS, or any framework of JavaScript, then you can already work with Electron.js. So yeah, that's a pretty powerful tool that you can learn. Until now, we talked about different tools and, front-end and back-end and then programming language and frameworks that you can use. And also we talked about npm.js and then, how you can version your application and how you can push or pull your code. And for example, now when you have created your application, how you can deploy it, or what are the services that you can actually deploy your code on, and how you can manage those services and all that. So that is basically, I created another separate section for that. That is called deployment, or I would just name it DevOps section basically, or basically the cloud engineering side of, when we talk about the cloud services over here. So the first thing that I'll talk about is basically the cloud providers. So you can basically publish your application, your web application on different cloud providers. So basically we have Amazon Web Services, we have Google Cloud, we have Microsoft Azure, we have Blue Ocean, we have Heroku. So personally, for the personal projects, I've used a lot of time Heroku that you can use, and deploy your web application in here. And a lot of companies nowadays are using Amazon Web Services, Google Cloud, and Microsoft Azure, and Blue Ocean as well. So if you ask me what my suggestion would be to choose from one of them, so I would probably vote for Amazon Web Services. I've been working with them for a long time. So I know how powerful it is and how you can manage your different infrastructures, and it's really, really good. It has a lot of different services that you can make use of. So it has basically the serverless framework actually that you can use. And basically what is serverless is that you no longer have to manage your servers. You just have to write your functions in Node.js or whatever programming language you're comfortable with. You just push it and deploy it, and AWS will take care of the servers for you. So you just have to choose the platform or the running environment for your application or your code, whatever. For example, Node.js, Python, or PHP, whatever you have written in your code in, and then it will take care of that for you by itself. And what is IAC? Basically, that is called infrastructure as a code. So basically, you don't have to go manually all the time to AWS and go for renting some machines for you, like how much RAM do you need, how much memory do you need for that, and how much CPU processors do you need. You can just use SAM CLI, CDK, or CloudFormation for that in order to deploy your infrastructure from your machine. That's basically pretty easy and good to learn actually. And if you want your career and basically as a cloud engineer, so I would go for Amazon Web Services. It's pretty powerful and used by a lot of companies, and it gives you a lot of flexibility in terms of managing your cloud services and all that. But if you're building your personal applications, for example, a Node.js application that you build, then you can simply use Heroku for that, and you can just simply deploy your application over there. So my first pick would be for the sake of easiness, I would vote for Heroku. If you want to learn first, then go for Heroku. And if you want to have an extensive career and as a cloud engineer, then you can just go for Amazon Web Services and just learn this one. And then also on the infrastructure as a code, you have different things like containers, and then provisioning, and then configuration management, and you have different tools that you can do that, or you can make use of. So basically on the container side, I would go for Docker that you can learn. Docker is basically a really, really powerful tool that you can learn nowadays to Dockerize your application and run your application in containers. And for the orchestration of your Docker containers, I would go for Kubernetes to orchestrate your Docker containers, basically where your application is running, and makes your application more scalable and takes care of your Docker containers in a very good manner. So I'll just go for Kubernetes. You can also learn Docker Swarm. Also for the provisioning, we have Terraform and CloudFormation. CloudFormation is basically specific to AWS, but if you want to work with Google Cloud and AWS and also Microsoft Azure, then Terraform is a good choice because it gives you the flexibility to deploy your infrastructure as a code on all of the cloud services. So it's not basically a platform specific or any cloud provider specific, not just AWS or not just Google Cloud or not just Microsoft Azure, but you can just deploy your code on any of these top cloud providers. So I would go for Terraform. And if you are working with AWS already, then you would already be dealing with CloudFormation. So what it uses basically behind the scenes to deploy your infrastructure. And the configuration management, or basically on the IAC, there are a lot of tools that you can use. For example, Ansible, Chef, Salt, and Puppet. My personal preference would be to learn Ansible first. It is a really powerful tool. The three of them, I would say that they're equal, and you can just they have their own pros and cons as well. But yeah, you can just go for any of them. But first thing, you just have to learn Ansible and configuration management for the IAC. Now we have the CI/CD. What is basically CI/CD? So basically CI/CD, continuous integration and continuous deployment. So all the time, if you make some changes to the code, you want to deploy it right away. So you don't want to have, a wait time, or zip your files and then upload it to your host, and then it will be live. So each of the change that you make, you just have to push it to any of the GitHub, GitLab, or Bitbucket, and from there these CI tools will be taking care of your application. Your application will be tested, and if you have some other steps for verification and code quality, so every check will be made through these tools, and then your code will be deployed to your specified environment. So usually we have three environments for a web application. That is basically the dev environment, or the local environment that the developers usually work on. Then there is the staging or testing environment. That's basically when your application is tested out. If the tests are successful and there are no bugs in your code and application, then they are just deployed to the production, and then they're live, and users can then use your features. So this is basically what we call CI/CD. It's good to learn almost of them, but it's not really possible. So I'd go for, if you're working with GitLab specifically, then you'll already be dealing with GitLab CI. So I would prefer to work with GitLab, because GitLab gives you some internal tools that you can work with actually. GitLab CI is one of them. So you don't have to install extra things in there and make it work. So GitLab CI is a really powerful tool that you can use on GitLab itself, and your code will deploy automatically through that. And then I would go for GitHub. GitHub is really good, and you can use GitHub Actions now that have been recently introduced. And also you can use some third-party tools like Jenkins and Circle CI, Travis CI, or Azure DevOps. But my first choice would be to go for GitLab CI and then GitHub Actions. Also, you can go for Jenkins if you want to learn third-party tools, and it's a really good tool, powerful. Also, Circle CI, and then you can go for Travis CI, or between these two, you can choose either of them. And now let's talk about logs management. So when your application is quite bigger and it has a lot of features, and if there is some problem and some bug occurs, some errors pops up, then you need to have some logs, and then logs should be managed. And there are a lot of tools that you can manage the logs through. So for example, if there's some error or bug that is reported by someone, then you can just go to your logs, check the logs, and see for that specific error, and that error message will give you a clue where this error is coming from, and you would know how to fix it eventually. So you can use these tools for your logs management, the Graylog, Splunk, and Peppertrail. But I personally prefer Elasticsearch, and I work with that. So you have Beats, Logstash, and Kibana. These are basically integrated tools. Beats is basically for the dataset or data stream, and the Logstash is basically for that, and for the logs, and Kibana is basically for the analytics and all that. And Elasticsearch is basically a really powerful search engine that has this Lucene format of searching data. So that is basically it on the deployment side. So you can see that we have a lot of things in here. It's basically more of a DevOps and cloud engineering stuff over here. So you can see we have the cloud providers, different cloud providers, and then we have the containers and Dockers, and then Terraform for the infrastructure as code, and then configuration. Then we have the CI/CD pipelines and all that, and then we have the logs management. So I hope that it would help you in your career as well. Now let's just talk about different interfaces and web development. So we have different kind of interfaces that you will be dealing with. The first thing is basically the graphical user interface that you can see, that's called GUI. So the graphical user interface is basically the graphics or the user interface that that's basically shown on the browser itself. So when you open, for example, google.com, you can see the search bar with the Google logo and a search button. For example, if you go to facebook.com, then you can see a lot of different components over there, your profile, your friend list, your messages and everything. So that's basically the graphical user interface that user can interact with directly with the mouse or hands and or anything that depending on the device you're using actually. So that's basically the graphical user interface. Another interface that we have is basically application programming interface, that is called API. So basically what happens in GUI and the graphical user interface, for example, you have a form and you want a user to log in through the form. So a user will have an email box, and then the user will have a password box where they can input the email and password. And on clicking the login button, login and password will be checked against the database. If the user is authentic, the user will be logged in into that appropriate website. So that is basically interacting with the application through the graphical user interface. What happens if I want to interact with the application using programming? So we have a lot of cases that we want to use the application programming interface. So the same user interface is basically replicated by an API is created for that. So you can just log in through your code, basically based on your code, you can make a login as well. So that is basically called API. So basically it's a connection between computers or between computer programs, and it is a type of software interface or programming interface offering a service to other pieces of software. So for example, login is one service that you want to use in other application, and you want to log into, for example, one application through programming from another application, then you can use the application programming interface. So in here you can see that we have different types of APIs. We call them REST. We have REST, we have JSON APIs, we have SOAP, we have open API specs that we can define our API first approach, and we can define our APIs list and the way we define it, and then we create open API clients for that, and we have the Swagger UI for that, where we can visually see our API in system. And then we have some authentication over here. So you have cookie-based authentication, you have OAuth, we have token authentication, we also have JWT authentication, we have OpenID and SAML. So these are basically the authentication methods that you probably will learn, but mostly people are using JWT and token-based authentication, and cookie-based authentication are not that used nowadays, but yeah. And also REST is one form of that, so you should learn REST API and how to deal with it and how to create different APIs. And then you can learn the open API specs, how to write your API specs. And in here in the authentication, I would suggest to learn JWT authentication and also token-based authentication. And then you can learn either of them if you want to, for the sake of knowledge. And then we have for the endpoint, unlike REST API, we have Graphql. It is a bit different, but it's really, really powerful tool where you create different models and then integrate with the Graphql, and through one single endpoint you can make a nested query to your database, and then you'll get the actual data. So the problem with the REST API is if you have different endpoints and you want different data. For example, for a user you want the blog post and comments for those blog posts, and you want the friends for the users. You'll be making a lot of requests to your backend. So to overcome that problem, Graphql was created, and we have a tool on top of that is called Hajra that gives you the interface, and you don't need to do any a manual configuration for that, but you just have to install the application, and it has its own client that you can work around it, and it's a really good tool to use. And also then Facebook created Graphql Relay that has more flexibility over consuming your data. So basically that's a good to learn. So if you're learning Graphql, then I think you must learn Hajra and Graphql Relay. These are really good tools, and it will give you a good overview of your skill set, and it will have a good impact on your CV or resume as well. So those are basically the two interfaces that we talked about. Now the third interface is basically CLI, that is called command line interface. When you're working with web applications, you're mostly be working with the command line, and you can use different tools over here. For example, curl, git, and grep or jQuery, and you would know how to SSH into remote machines, or different servers and all that. Most of the time, if you're working with applications nowadays, so if you're working with any JavaScript frameworks, then you will be using the command line mostly to run your applications. And also it's useful for bash scripting, so you can use either Vim, Nano, or PowerShell or Emacs, but I would personally suggest to go for Vim and then Nano if you want to. So yeah, that is basically all about the interfaces and web development. So we have talked about graphical user interfaces, application programming interfaces, and then command line interfaces, and how you can learn them, and what to learn, and what is important, and that you can learn from here. At least you will have knowledge of what are these interfaces now. Now let's talk about web security over here. So in web security, we have hashing, that you can encrypt data or then decrypt data, and then we have some common security concepts and web development. So in hashing, you can learn MD5, but that's all that it's not necessary to learn. But then you have SHA family, crypt, and bicrypt. But yeah, I would personally go for these three if you want to learn them, and they're really good and powerful. And also in common web security concepts, you can learn HTTPS, CORS. So you should learn HTTPS, which is Hypertext Transfer Protocol, secure, what is CORS, cross-origin resource sharing, and then CSP, and then SSL, TLS, and then what that has the top 10 standards of security that you have to learn. So basically, these are the key concepts of the web security. If you're a web developer, then you must know these things. And then we have design and development principles. So we have TDD, that's basically called test-driven development. Then we have BDD, that's called behavioral driven development. And then we have domain-driven development. And then we have solid principle, and that is basically acronym for 5 design principle intended to make object-oriented designs more understandable. And then you have this KISS principle, and then you have don't repeat yourself principle. So all of these principles that you should know, and you could often be asked in the interviews as well about these principles. And also, if you're working and testing your applications, then you should know TDD, BDD, or DDD. So these are basically the very core and basic principles. Then in testing, we have, personally, most of the time people use unit testing, to test your each unit of your code separately. And then we have end-to-end testing, where you test a full feature from start to the end. And then we have integration testing to test some modules or some components of your code combinedly. So basically, unit testing and end-to-end testing and integration testing is a good concept to learn and work around. Then we have the concept of caching. You should know how caching is done and what is caching actually. We have actually 3 types of caching. That is basically client-side caching, and we have the content delivery network that basically cache your data. And also we have server-side caching that can be done by either of these two. Redis, that is basically a key value pair database that basically caches your data. And also memcached, and also that has been used for the same purpose. So basically, these are the key concept or the core concept that you must learn. What is CDN, content delivery network, and how it caches your data. What is client-side caching, and how you can approach different client-side caching methodologies, and what is server-side caching, and how we can cache data between the database and our business logic or the backend. Now, apart from this, we have talked about a lot of things on the web development side. So until now, we've been talking about web development, and then front end, back end, and then how to deploy your application, how to use different tools to control versions, and then how to use the package manager, and what package manager do we have in place. And then we talked about different interfaces, and we talked about web security, we talked about design and development principles, we talked about testing and caching. Now we have different services, or we have some ready-made applications or web application or websites that we can use to create our own applications. We have two types of websites out there on the internet that we can use nowadays to build our applications, basically to build our websites. One is called content management system, that is called CMS, and one is called website builders, where you can create, some static website and even some dynamic websites with data, like for different purposes, like e-commerce websites and, for example, a blog post and something like that. So you can create this kind of website with these tools. We have on top, we have WordPress, Magento for e-commerce, used mostly Drupal, Joomla, and then we have Wix, Squarespace, and Weebly. Most of the people are nowadays are using these tools in order to build their websites for the sake of easiness, because it's pretty quick to use and easy to use, and quick to develop and deploy your websites. And it's basically mostly for the people who are programming illiterate, and you can, up to some extent, you can also add your code and customize it in your way, and you can add your PHP code or JavaScript and everything. But yeah, if you want to build a scalable and more powerful application and more custom application, then you cannot make use of these kind of tools. So if you have some kind of website, for example, a portfolio you want to build, or an basic e-commerce store that you want to build with some payment gateways, and you have some products to sell, then you can use Magento for that, or Wix and Squarespace, or whatever you want to use. But you should know that there is a bit difference between the content management system and the website builder. So basically, website builders build your website from scratch, and the management systems actually gives you the flexibility to design, to make your own design and create your own pages on top of these basic management systems. For example, you have an e-commerce store, you can design the theme for that, and you can add different products and all that to that, and it will be already taken care of. So the database, website, and all of that, the database, the front end, and everything is taken care of. So these are basically the tools or services that you can use from the internet nowadays, and they're pretty cheap, and you can just deploy it in one day your web application. Last but not least, let's talk about the architectural pattern. So what kind of applications do we have? So we have monolithic applications, we have microservices architecture, we have SOA, that is called service-oriented architecture, and then we have serverless architecture. So what is basically monolithic application? So a monolithic application is basically a self-contained and independent from other computing application. And it describes basically a single tiered software application in which the user interface, the data access code are combined into a single program from a single platform. So you can see it's basically a traditional web application monolithic architecture, and you can see we have this UI layer on the top. And then we have different services, for example, account services, and our order service, book service, shipping service. And then, for example, from any device, for example, a desktop, mobile, or browsers, you're making a request to the server, and you can see it is interacting with the databases, and your business logic and the front end, everything resides in a single container. Whereas the microservices architecture is a variant of the service-oriented architecture structural style, arranges an application as a collection of loosely coupled services in a microservices architecture. So in a microservices architecture, for example, this is a user or a client, and this is for example, a user has a desktop, mobile, or whatever, and they're making a request. So you can see all of the services are divided now to microservices. So this could be a login service, this could be the payment service, this could be one service and another, and all of these services are divided into different into their own containers. And through the API gateway, when you make a request to this API gateway, it will forward your request to the respective microservice, and then it will deal with the database, and all of your business logic resides inside a single microservice. So each services are loosely coupled, and you can deal with it like so. That's basically the microservices architecture. And then we have SOA, that is basically called service-oriented architecture, and it is a type of software design that makes software components reusable using service interfaces that use a common communication language over a network. And then we have a serverless architecture. So basically, serverless architecture is a cloud computing execution model in which the cloud provider, for example, Amazon Web Services, Google Cloud, or Microsoft Azure, allocates machine resources on demand and taking care of the servers on behalf of their customers. Let's say you want to build your website, so you don't have to worry about the servers, and you don't have to write any code for the servers and how to deal with that. So everything will be taken care of by the providers themselves. You just have to write for example, your handlers, your code, and then you just deploy it, and then the servers will be taken care of by the providers themselves. So that is basically all about the architectural pattern, and I think we covered almost everything in the web development. And you can see that we have a lot of things over here that we can learn. So that's it from my side, and I hope you have learned something new and you have some more information and insights of what is basically web development and how what is the pathway or roadmap of web development, and what are the tools and technologies that you have to learn in order to be a good web developer. And in the next video, I'll be talking about front-end engineer. We'll be talking about backend engineer. We'll be talking about cloud engineer specifically, and we'll be talking about full stack engineer and what are the roles and responsibility of these engineers in different projects or companies. So make sure that you watch that video as well. And until that, I'll see you in the next video.